Now that we have understood about the feature selection and how it can be performed, let's try to understand about the next important thing that you can do as part of the data preprocessing, which is handling the missing data. Now, when it comes to missing data, it's usually a problem because the machine learning model requires data to work upon. So if the values are missing, we wouldn't be able to utilize those values in order to build the model. So we can't exclude that data also many a times because it could be a lot of data that we would end up losing in that process. So we need to do this thing thoughtfully of how we are going to handle that missing data. So whenever missing data is seen as part of a data set, we have to solve this problem by either eliminating that missing data or by treating that missing data. Now, there are very simple rules that are applicable here, that if it is very less amount of data that is missing overall in the data set, we prefer eliminating the data because there could be missing values scattered across the entire data set, and rather than filling those values, it is easier to eliminate them. So we can simply drop that missing data and we can proceed with the rest of the data. But when is this suitable? Only when there is less amount of data that you're going to lose as part of this elimination process. Let's say if you're going to lose a lot of data, you are actually going to get a bad model when you are building it. So there is no point eliminating a lot of data. So elimination is an option only suitable when less amount of data was missing. But when there is more amount of data that is missing, we would ideally prefer to treat that data. And when I say treating the data, what I mean is we can fill those missing values with some genuine values over there. And when it comes to filling the missing values, the immediate next question that arises is, how do we fill them? Of course, there are various techniques that we could use in order to fill them. But the very first thing that a person should do is go to the client. Tell him that these are the variables where these are the missing values that I have observed. Help me fill them. Seek help from the client. It is his data, so he'll be able to guide you better in terms of what values could be present over there. Sometimes he might have those values into some other files with him. So he can fetch those values and give it to you. Sometimes he may also have to reach out to the customers to get those right values for you. But that's his part of job, and he will ensure to get those real values for you, because the more realistic the data is, the better your model will be trained upon. So this is where he might help you in filling the missing values. Some cases are such where there could be some default values that could come, and the client knows what are those default values to be filled. So he can tell you that this is the default value to be used in order to impute certain variables. So you are done there. You are able to fill some more variables on the basis of that. And beyond this, if you are still left off with certain variables where even the client could not help you get the real values, then you are onto your own. This is where you can use very simple approaches like, your measures of central tendency, like your mean, median, mode, can be used in order to fill those missing values. Of course, there are other ways as well in order to fill. You have, the forward fill, backward fill kind of functions that can help you, repeat the previous or the next value in place of the missing values. But even the measures of central tendencies could be useful, where you can use the mean or median for the numerical variables to be imputed, whereas the mode can be used in case of the categorical variables to be imputed. So such kind of imputation where you are using measures of central tendency is ideally where you are assuming that this could be the value. We know that that wouldn't be the exact value, but we have some value instead of the missing value. So once the missing values are filled, we have the entire data to proceed with. So this is how you can work upon the treatment approach when it comes to handling the missing data. So as we discussed, you can either eliminate the data or you can treat the data. And there are various techniques using which you can treat the data. There are also certain inbuilt functions available in the libraries which support machine learning, which will allow you to impute those missing values automatically on the go. So you can even make use of such kind of functions. But handling the missing data is a very crucial step, because if you have even a single missing value present in your data, your model is going to throw you an error, because missing data is something that the model cannot handle, because what goes behind the machine learning algorithms, as we discussed some time back, are the statistical techniques. So if there are certain statistical formulas that are going to run behind the scenes, it requires the data, right? We can't pass missing data there because the formula will throw an error. So we definitely would have to handle the missing data as part of the data pre-processing step. And once you have handled all the missing data, you have the entire data to work upon, that's where we proceed with some other transformations. And another thing that you can do with respect to cleaning the data is the outlier handling. Are you aware of what are outliers? Outliers are the extreme values which affect the data. Suppose, for example, I have a variable like salary where I have the salary of all the employees of the organization. Now, within this salary, the actual range of the salaries that are received by the employees is somewhere between 20,000 to up to 2.5 lakhs. But suppose if there is the CEO's salary also included into this variable, that will be a very high value, right? Let's say, for example, 10 lakhs per month. So in this case, if you see that extreme value is an outlier here because it skews the rest of the distribution. So that is where we should be eliminating such kind of extreme values, because that will affect the mean and the rest of the statistical values, and our results could not be reliable. So if at all we have any outliers in the data, it is ideal to get rid of the outliers and then process the model building part with the rest of the data. But having said that, let me also tell you that there are certain machine learning algorithms which are robust to outliers. They do not get affected even if there are outliers in the data. They ignore those outlier values and they work upon the majority of the data. So if you want, you can consider this as an optional step, but it is ideally a good practice that you handle the outliers before you proceed with the rest of the things. So now, once you have handled the outliers, you probably have the right kind of data to work upon, the right set of observations also, and the right set of variables also, because you have done the feature selection as well. So now, once you have that entire data with you, you can proceed and work upon some other transformation related steps. And when I say transformations, what are some of the common transformations? Let's discuss that. Now, if you see the data, there could be a lot of uh, mixed data type of variables that you could be dealing with. Let's say, for example, I have variables like, salary, which could be numerical, but at the same time, I could also have a variable like gender, which could be categorical. I could have the department names for the employees, which could again be categorical. Now, the problem is, as I mentioned some time back, what goes behind the machine learning algorithms are the statistical functions, right? And in order to run the formulas, what we require is numeric data. So if at all our data set consists of categorical values, that again becomes a major challenge, because categorical values is not something that the machine learning model can handle. So when you try to build a model with those categorical kind of variables, you're bound to get an error. So it is a mandate step that you need to perform, where you'll have to convert your categorical data also into numerical values and then feed it to the model, because then is when the statistical functions or the equations will work fine. So that's where you work upon the conversion of categorical data to numerical. And again, in order to perform this step, there are different approaches that you can make use of, where you can either manually encode the data, where you will decide, what numerical value should be associated to which variable, or you have some sort of inbuilt functions also available, which automatically encode the data for you, and you can just proceed with those set of variables where the values have been converted from categorical to numerical. There are multiple ways to do that, but we are not going to deep dive into those details as of now, because that will shift our major focus. So conversion of categorical data to numerical is again mandatory step that you need to perform. Given that any single categorical value is found, your model will throw an error. So this is where, after converting the entire set of variables to numerical, we are at such a stage where we can use that data and go ahead and build a model onto it. But there is one more step that I would like to, discuss upon over here, which is usually a good practice, even though an optional step that you can perform, but it's a good practice that you scale your data. Scaling the data is a good practice because whenever you work upon multiple variables that are given to you as part of the data set, you would be working on different units and different ranges of the variables. Let's take a very simple example. Suppose you have the age of the employee as well as the salary of the employee present in the same data set. Now, if you think of the ranges that are present for both of the variables, age is such a variable where the values could be usually ranging from 1 to 100, right? But at the same time, when it comes to the salary of the employee, you would be having the value anything between, let's say, 10,000 to maybe even 10 lakhs. So you can see the range is quite different for both of the variables. But it's not just the range, right? Even the units would be different for both of them. Age could be given to you in years, whereas the salary could be given to you in rupees or dollars. So that's where the units also differ. And when such kind of discrepancies are present in the variables in the data, it is very crucial that you bring the data into a uniform format, because there is a chance that your model might get biased onto the variable like salary, because that has a larger range, so it will start assuming that salary is more important than the age variable. But we don't wish to train the model on such kind of details, right? So that is where we will ideally bring the data into a uniform format and also make it unitless, such that we will be able to utilize that data and train the model efficiently onto it. So this is where there are steps like, normalization or standardization that we can apply onto the data that will help us bring the data into a uniform range also, and make our data unitless also. And these are very easy to apply kind of techniques, because we have some direct inbuilt functions which will help us do that. So once we are scaling the data and bringing it into a uniform range, there is no chance that the model might get biased onto some of the variables and focus only on those. So this is where scaling the data is an optional but a very important step that you can perform as a good practice, so that your model is a even more reliable model. So these are the certain steps that you can definitely perform while you are trying to transform the raw data into a clean and processed kind of data. And once you are done with transforming the data, it's ready to be fed to the model. That's where you work upon splitting the data. And when I talk about splitting the data, I will try to split the given data into the training and the validation data. Now, what is this and why is this needed? Let me help you understand that. So when the client gives you the training data, he would ideally give you the entire data along with the expected outcomes also. So what I'm talking about is that your data could have the independent variables as well as the dependent variable. Okay. Now, in terms of machine learning, we call the independent variables as the X variables, and we call the dependent variable as the Y variable. Let me set the context around this independent and dependent variable. Independent variables are those variables which will contribute to help you find the value for the target variable, which is the dependent variable. So that dependent variable is dependent on all of the independent variables that you have. For example, if I am trying to help you relate to that same example that we spoke about previously, suppose if I am trying to find out whether a given credit card transaction is a genuine one or a fraudulent one, the variable there is this two values, right? The genuine or transaction, the status of the transaction, whether it is genuine or fraudulent. So that becomes my dependent or the Y variable, or as we call it, the target variable. Now this variable is dependent upon several other independent variables. Now what are these independent variables? These are nothing but the transaction related details. So who was the sender, who was the receiver, what was the amount of the transaction, what was the date and time of the transaction, what was the location of that credit card transaction. All of those details that have been given to you with respect to those transactions, those are your independent variables. Based on the values that are present in those independent variables, you will be able to decide the status of that transaction, whether it is a genuine one or a fraudulent one. So your independent variables are known as your X variables, and your target or the dependent variable is known as the Y variable. So now when you are working on splitting the data, you will be taking the entire training data or the historical data that was given to you by the client, and you will try to split this data into training and validation data. Now, why is this required? Because in the training data, or let me put it this way, in the training phase of the machine learning model, you will be feeding this trained data to the model, because this has both the X and the Y. So you will be teaching the model that if these were the details related to the transaction, then this was the status of that transaction. Okay. Now, once the model is learning onto it, we discuss that we need to evaluate the model as well to understand whether the model is giving us the correct results or not. And that is where the validation phase comes into the picture. And we do require some data that needs to be fed into the validation phase, correct? So this is where we will split certain amount of the data into the validation set. Now usually the percentage of data that we reserve for validation is either 20% or 30%, depending on the amount of data. If you have a lesser amount of data comparatively, you will prefer a 80-20 kind of a ratio, where 80% of the data will be utilized for the training part, and the remaining 20% of data will be utilized for the validation part. If your data is large enough, you can even go to a 70-30 kind of a ratio, where 70% of data will be utilized for training, and we will try to validate the model on the remaining 30%. So when that is the kind of scenario, we need to reserve that 20% or the 30%. So that is where splitting the data becomes an important step. And why do we need to use the validation data from the actual historical data only? I'm sure you must have got this question, right? Now, this is because we require both X and Y when we are going to evaluate the performance of that model. So, when we will be using the trained model in order to validate on some unseen data, we will require to pass the X values to the model. Okay. So now this is where I will be telling my model, on the basis of the training that you have received, you tell me what are going to be the Y values for these given X values. And based on whatever learning it has got, it will try to apply that logics onto this set of credit card transaction details in order to find out what could be the Y predicted value that we have got. So the model will give its own predictions. But in case I need to compare it with some actual values, I need those actual values with me, right? Because without comparing the Y predicted versus the Y actuals, I'll not be able to justify how good or bad is my model. If it is a good one, good for me. But if it is a bad one, we have discussed already that we need to improvise the performance of that model, isn't it? So that is where we will require such data where we have the Y actual values, but on the same data, we will let the model predict the values. Once the model predicts, we will be able to compare those Y actuals with the Y predicted, and that's where we will be able to understand the performance of the model. So the validation data will have the X as well as Y, but what we will end up doing is we will just pass the x values to the model such that the model gives us the y predicted values, and based on that we will try to compare the y actuals and the y predicted, which is nothing but your evaluation phase. So in the evaluation phase we will compare the y actuals versus the y predicted. So this validation data had your y actual and the model gave you the y predicted. We will compare both of them and we will decide whether or not it is a good model. Alright. So this is where your evaluation process is completed. Now, once you are, okay, let me name this as the 7th major step here. Okay. Now, once you are done with the evaluation, if your model is a good model, good for us, right? As we discussed, we can go ahead and we can deploy that model for the client. But this is a very rare scenario that you'll get a good model in the very first attempt. So you usually require to improvise the model by looking at its performance. So if your model is giving you, let's say, 80% good results, you will still strive hard in order to, get an even better result. And that's where we move on towards the tuning phase. So tuning phase is where we will be trying to improvise the model using different approaches, just with the aim to get a better result with the model. Now there are various tuning related techniques that are available, but all in all, what I want you to understand is this is a very crucial step again, because this tuning will help you get a better model. So when you are tuning the model, what you are going to actually do is rebuild the model. And when you are rebuilding, you will again work upon training the model. You will again work upon validating the model on the small amount of data that you had reserved for validation. And you will again evaluate the model to see if your performance of the model has improved this time. And you'll keep on repeating this multiple times using different approaches to see which approach is more suitable for that particular problem. And then once you are satisfied with the results that you are getting, that is where you will stop the process. So this is where you will actually build a final version of the model that can be used and taken ahead to deploy. And this deployment will be the application phase that we discussed some time back. So let me take you back to the slideshow where we were talking upon the various phases that we had, correct? So this is where we will try to clean and prepare and manipulate the data, where all of those pre-processing steps that we discussed will be falling. And once the model has been, once the data has been pre-processed, it is ready to be fed to the model. As we discussed, we will split that data into the training and the validation data. So the training the model wala phase is the next major phase that we work upon. And as I said, we will try to test it on the validation data. So some amount of data on which we will try to test it and understand the performance of that model. So that's where your evaluation phase also comes into the picture. And based on the results that you see, as I said, we will try to improvise or tune the performance of the model. So fine tuning the model is a kind of repetitive step that you would perform. So step number 3, 4 and 5 that you see here are going to be kind of, repeated in a loop until you reach the best possible model where you are satisfied with the results and you decide that yes, this is the final version of the model that I would like to use. And then once you have got that final version of the model, that's when you go ahead and you work upon the deployment stage. So deployment is ideally one of the last steps that you perform for the client, because that is where you will be handing over the model to the client. So it's a complete product that you deliver to the client and not just your code file where you have built the model. So the deployment stage or the deployment phase is where your software developers also come into the picture. It could be a desktop application that you could be building for the client, or it could also be a kind of a mobile application, or it could be a web application, or you could deploy it onto the cloud platform. So there are multiple platforms on which you can deploy the model depending upon how the client is going to use that model. But once that deployment is done, the client does not have the dependability on you. He wouldn't require your help every time whenever a new data arrives and we need to do the predictions for it. Your machine learning model will sit at the background, and as in how new data arrives into the system, it will be able to process that data using the similar data pre-processing steps that you had applied onto the training data, and it will use that data in order to predict. And that's where whatever predictions your model gives you will be given to the client in the form of a report, such that he can take the next action onto it. So that is what the deployment phase is related to. Now, just to tell you, there is one last step that could also be a part of your project. Okay, ideally it will be a part of every single project, but sometimes you may have to work upon that step quite a lot. Sometimes the frequency could be lesser. Now, this step that I'm talking about is nothing but the maintenance of the model. Now, what happens is, once you are building and deploying a particular model, we can't use the same model for a long run. As in, I built a model, I can't keep on using it for 3 years or 5 years. I need to update it periodically. And that is required because new data would have got generated by then. Some patterns and trends would have changed by then. So we need to update and improvise our model on the basis of that upgraded data. So that is where maintenance of the model also becomes a part and parcel of the entire project. And that's where there will be still a little bit of dependency on you once the model has been deployed. So this is where maintenance of the model is one of the last but an ongoing or a recurring kind of activity that you may have to perform as part of the process. So these are certain major steps which you will always observe when you are working as part of a machine learning project. And there could be certain steps which could change their order, but you will always have to work on all of these steps to get your entire machine learning model up and working.